Hello everyone, welcome to Permutations and Combinations. So permutations and combinations is all about counting the number of ways that you can do something. To start off with, let's look at the basic counting principle. If task A can be performed in m ways, followed by task B that can be performed in n ways, then task A followed by task B can then be performed in m times n ways. So imagine there are 3 ways to perform a certain task. For example, there are 3 different foods you want to eat. And then you may have 2 different drinks that you may like to drink. What's the total number of ways that you can choose 1 food and 1 drink? So by the basic counting principle, this is just 3 times 2. This actually gives you 6. So we have 6 ways of picking out 3 food and 2 drinks. Next, let's introduce the factorial function. Alright, so the number of ways to arrange n distinct objects is just n factorial, which is 1 times 2 times 3 all the way until n. Okay, let's say we have 4 spaces and I want to arrange the numbers 1, 2, 3 and 4. So in the first space, I can put 1, 2, 3 or 4. So there are 4 different ways. And for the next space, if I already chose one of the numbers on the first space, I can actually only have 3 possible numbers because one of these numbers have already been chosen for the first slot. So, similarly, they are only left with 2 choices for the third slot and 1 choice for the last slot. And that's how we get 4 factorial, or in a general case, n factorial. So now, let's move on to something a little bit more complicated, permutations. So, as I denoted up here, permutations is all about position. It's where you position or arrange certain items. So the number of ways to arrange r different objects from n distinct objects is just npr, where you have this formula over here. Well, this formula is given in the formula booklet, but I don't actually like to use it. What I like to do is if I need to calculate it manually, for example in paper 1, I have a different way of calculating it. And in paper 2, I'll just use the calculator. So how do I calculate this if it's given in paper 1? Let's say we want to arrange 3 objects from 10 different objects. So maybe we have 3 different spaces and I want to arrange numbers 0 to 9. So I will get 10p3, which I can calculate this as 10 times 9 times 8. So what 10p3 does is that I will start from 10 and then count all the way down 3 times. So something like 10p4 will actually just be 10 times 9 times 8 times 7. And in case you wanted to know the GDC notation, you write NPR and bracket n, so in this case we have 10, comma r. In this case we have 3. Again, let me remind you, permutations is all about positioning or arranging different things, okay? Later we will learn about combinations, which is a little bit different. So let's try out a question. If 4 boys and 5 girls are to form a line, how many ways can this be done if there's no restriction? So if there's no restriction, this is just arranging 9 objects into 9 distinct spaces, which we know this as 9 factorial. So this is just simply 9 factorial, which is 362,880. The next one, if 4 boys and 5 girls are to form a line, how many ways can this be done if the first 2 must be girls? So if the first 2 must be girls, let me denote this by writing G and G. So the first 2 must be girls, and the 7 doesn't really matter what these 7 are. So let's do this. For the first 2 spaces, we want 5p2 because we are arranging 5 different girls into these 2 different spaces. And then we'll times by whatever we need to do here, which in this case, we're just arranging the 7 remaining people. So this is just times 7 factorial, which will get 100,800. And for the last one, no 2 boys can stand beside each other. So what I'm gonna do is draw all the girls over here. I have 5 girls and I'm drawing arrows all between the girls because that is where the boys can stand. So over here, what we're doing is assigning 4 boys to these 6 different spaces, which is akin to 6p4. So 6p4 is just for the boys, but for the girls, we are just rearranging the 5 girls into the 5 different spaces. which is 1, 2, 3, 4, and 5. And since we're rearranging the girls, the 5 girls is just times 5 factorial, which we will get 43,200. Let's take a recap. For part A, we have 9 factorial because we have 4 boys and 5 girls, but it doesn't matter. So we just have 9 people being rearranged into 9 different spaces. The next one, 5p2 over here is when we take the 5 girls and arrange them into 2 different spaces. So this is just 5p2 and then times 7 factorial because this rest of the 7 can be rearranged however you want as long as it's in this line. And in the last case, we are assigning 4 different boys into one of these 6 spaces between the girls such that no 2 boys stand beside each other. So we are just assigning 4 boys to these 6 spaces, which is just 6p4 ways to put the boys. And then we'll times 5 factorial for the girls because we have 5 girls being arranged in 5 different spaces. Hopefully that was a clear enough explanation. The next thing is combinations. Here, combinations represents choosing different people, choosing or selecting different people. This means that the position does not matter. What is the difference? For example, if I want a combination, ABC is a combination. But a permutation will not only include ABC, but ACB, BAC, BCA, CAB, and CBA. Every single possible way to position ABC. Alright? So what combinations only care about is just that this combination of ABC is together in a group. But it doesn't matter how this group is being positioned. So we have that the number of ways to choose R objects from n distinct objects is NCR or n choose R. And if this is familiar, this is actually your binomial coefficient, which you have seen in binomial theorem. Again, this formula is in the formula booklet, but we're not going to use this. In paper 1, I've got a separate way of doing it, and in paper 2, you just use the calculator. So similar to 10p3, for 10c3, you have 10 times 9 times 8. But in this case, you'll be dividing by 1 times 2 times 3. So you have 3 numbers at the top and at the bottom. Another example, let's say I want 4c2, I'll have 4 times 3 at the top. I have 2 numbers at the top, and starting from 1 at the bottom, I'll have 1 times 2. So right now, let's do the question. Out of 8 year 1s, 6 year 2s, and 2 year 3s, find the number of ways that 6 year 1s, 4 year 2s, and 1 year 3 can be selected. So this is choosing. So we use combinations. So we want to choose 6 year 1s from 8 year 1s. So choosing 6 from 8, this is just 8 choose 6. And then we'll be multiplying by the number of ways that we choose the year 2s, which is 6 choose 4. Because we want to choose 4 year 2s out of the 6 year 2s. Lastly, we want to choose 1 year 3 out of the 2 year 3s. So this is just 2 choose 1. This will net us 840 if we key in this to the calculator. One important thing, we are multiplying here, again, because of the basic counting principle. We are finding the number of ways to do task A, multiplied by the number of ways to do task B, and then multiplied by the number of ways to do task C. Now let's introduce a little bit of counting strategies. Okay, the first counting strategy we're going to cover is casework. So what is casework? It's basically splitting what you have into different cases. So you can consider different cases and count the number of ways for each case. Alright, Tim is thinking of a 5-digit number that uses the digits 0, 1, 2, 4, and 8. Find the most possible wrong numbers guessed if repetition of digits are allowed. So let's look at this. If repetition of digits are allowed, let's write my 5-digit number first. This means that in all the spaces, I can have 0, 1, 2, 4, and 8. Over here, I can also have 0, 1, 2, 4, and 8. The only difference is the first space because we cannot have a 5-digit number that starts with 0. So on the first digit, we can only have 1, 2, 4, and 8. So again, we have 4 possibilities times 5 possibilities because you have 5 numbers times 5 times 5 times 5, which is basically 4 times 5 to the power of 4. And if we calculate this right, we will get 2,500. Is this right? Mostly, we are just missing out one more thing. They ask for the most possible wrong numbers guessed. So this is the total number of possible numbers guessed. But if we want the most possible wrong numbers guessed, this means that the last guess must be a correct guess. So the most possible of wrong numbers guessed, we just have to minus 1, which is 2499. The next one, repetition of digits are not allowed and the number is also an even integer greater than 40,000. Phew, that's a lot of conditions. So maybe, because there are so many conditions, we may want to use a little bit of casework. So, first of all, let's evaluate how to do this. We have an even integer that is greater than 40,000. So if it's greater than 40,000, this means that the first digit has to be 4 or 8. It cannot be 1 or 2. And for an even integer, this means that there's 0, 2, 4, and 8 as your last digit. Okay, since we see a little bit of repetition here, we have 4 and 8 and 4 and 8 over here, maybe let's introduce a bit of casework. Okay, our case 1 will be when 4 and 8 is the last digit. And naturally, our case 2 would just be the other side when we have 0 and 2 as the last digit. So if you have 4 or 8 as your last digit, this means that there are two different ways of choosing your last digit because you're choosing 1 out of 4 and 8. And then, if we are choosing 1 of 4 and 8 as the last digit already, that means the first digit, we only have one possible way left. So this means that your first digit is just 1 times the rest. And the rest of the digits, we actually can just choose any of the 3 remaining digits from 0, 2, and 1. So the rest of this would just be 3 factorial. Again, for 0 or 2 as the last digit, there are only 2 possible ways. Again, we're not considering the 4 and 8 here, we're only considering 0 and 2 as the last digit. So if you have 0 or 2 as the last digit, this frees up the first space for 4 or 8. So this means that there are 2 different ways of choosing your first digit, either 4 or 8. And again, we have 3 remaining numbers left. So what I'm going to do is say that this entire thing over here is 3 factorial, or 3 times 2 times 1. So what we want to do is take 1 times 3 factorial times 2, and this time we are not multiplying, we are adding up the cases together. Because these are different cases where we add up the number of ways. This is not the same as the basic counting principle where we're doing task A followed by task B. This is one task being split into 2 parts so that we can add them back together. So if we calculate this out, we get 36. And again, we need to minus 1 so that there are 35 possible wrong guesses. Hopefully you are still hanging on tight. The last thing is complementary counting. So what is complementary counting? Okay, let's say there are only happy and sad people in the world. If we take the total minus the happy, then we can find the sad. Simple enough, but let's say I have more emotions. Maybe I have angry, I have scared, maybe I have shocked. And I want to find the total number for this. Instead of doing this plus this plus this plus this, what I can do instead is total minus the happy. And I will get the total number of ways for this. So that's the basic principle of complementary counting. So let's do this question. A team of 4 girls are to be selected from 8 girls. If 2 of the girls, Petra and Min, cannot be selected together, find the total number of teams that can be selected. So essentially, what this question is trying to ask us to do is take the total minus the number of ways that Petra and Min are selected together. Because if we do this, we'll get the number of ways that Petra and Min cannot be selected together. This is because Petra and Min being selected together is the complete opposite of them not being selected together. Alright, so let's start. Our total number of ways is choosing 4 girls from 8 girls, which is just 8 choose 4. And the number of ways that Petra and Min are selected together is actually 6 choose 2. Because right, out of the 4 spaces that can be selected, what we want to have is that 1 is selected for Petra and 1 for Min already. At the start, we have 8 girls, including Petra and Min. But since Petra and Min are already selected together, right, this leaves us with 6 girls left to be placed into the 2 remaining spaces. So this just gives us the number of ways that Petra and Min are selected together. So again, since them being not selected together is the complete opposite of them being selected together, if we take the total minus the ways that they are selected together, this will give us the ways that they are not selected together, which is 55. And for the final one, there are 8 boys and 7 girls in the club. Find the number of ways that 6 people can be selected if at least 2 girls are selected. So when I see the word at least, I may want to think of complementary counting. So what are the different ways of selecting this? We can have 2 girls, 4 boys, 3 girls, 3 boys, 4 girls, 2 boys, 5 girls, 1 boy, or simply just 6 girls. But this is a lot to calculate. This is 5 different calculations. But instead of doing that, what we can also do is take the total number of ways that this committee can be selected and minus 0 girls, 6 boys, and 1 girl, 5 boys. And that will give us the rest of the possible options. You can see that these two are opposites. And adding all these cases together gives us the total possible number of cases. Just like adding Petra and Min being selected together and Petra and Min not being selected together, these two are complete opposites. That's why we can use complementary counting. So let's do this. We want the total, which in this case is 15 through 6. We don't care who is being chosen in a club. We just want 6 people out of these 15 either boys or girls. And then we'll take minus 8 through 6 for just 0 girls, 6 boys. Why? This is because we are choosing 8 boys into this 6 people. And then what we're going to do is minus 8 choose 5 because we're choosing 8 boys into 5 spots times 7 choose 1 in order to get 1 girl, 5 boys. And this should net us 4585. Okay, here's the summary sheet for permutations and combinations. So to recap, we have permutations, which is about the position when we are arranging different people into different positions. Okay, combinations, which starts with C, so this is about choosing different people, okay, where position and order doesn't matter. And for counting strategies, we can do casework, where we're actually just adding up all the different cases to give us the total number of ways. And finally, we have complementary counting. Thank you so much for watching. I hope you guys understood how to do permutations and combinations. These are mostly very common standard questions that IB asks, so please do make sure to remember how to do them.